All right. Hi, everyone. Thanks again for for attending. This is the third webinar series for the year that we're hosting today, and I've got my colleagues here, George and Bhavani. We want to walk you through the journey on Solargraf today. I know most of you probably use the platform today, but we want to always keep you updated with the new features that are coming up and features that are already launched, and we want to make sure that everybody's using the most enhanced features in order to provide the most accurate estimates on your designs and proposals. So I'll just give it a few minutes to more people join to give a fair chance for everyone. And guys, I just want to remind everyone, if you have questions, please post them in the chat box below. We will have a Q&A session at the end, excuse me, and we will actually answer questions as my colleague George goes through a demo. So I'll just give it another minute or so and we'll get started, and I'll walk you guys through the agenda. All right, in the meantime, as people are joining, so I'm going to introduce our guest speakers today. Myself, I'm part of the Solargraf team. I run business development and sales for Solargraf and design services. We've got Bhavani here as well. She's our senior director for product and customer success. And George, pretty famous guy in the solar industry. He's the guy behind all the magic that's been happening and all the features and the design tool that you're going to see today. So he'll be running our demo. So he's a product manager on the Solargraf platform. Excellent. So quick rundown on the agenda for today. I'm going to give a quick overview of the Solargraf platform, just for those of you who are not using Solargraf today or seeing Solargraf for the first time, to give you a general idea of what the platform is all about. We'll have a few poll questions just to gather some feedback from those of you that are using Solargraf today and your experience with the new design tool. And then we're going to have George run through a full demo highlighting some of the new features that we have and some that are still in beta. So auto roof detection, few clicks, one click, you're able to detect all the roof lines on the design, use the wizard to generate a 3D model, detect obstructions, pitch, azimuth, trees. Our smart designer, which is a new feature that we launched that enables you to basically place panels in a smart way. The system does it for you. So we'll dig into that a little bit more in detail. And then we'll talk about PCS, which is a feature currently in beta, due to come out very soon this month. We'll also show a few designs on how power control systems avoiding main panel service upgrades reflect in Solargraf. And then we'll cover the battery design tool really quick, maybe a quick glimpse on the proposal, and then we'll open it up for a Q&A session. All right, just to get things excited, I'm going to launch the first poll question. I'd really appreciate if you guys give us your answers. So the first question is, do you currently use Solargraf for your solar designs and proposals? If yes, do you actually use the 3D design tool? And this is an important thing for us to know because we want to make sure everybody's using the latest version of Solargraf. All right. Okay, give it another few minutes. Be honest, guys, it's fine. We want to really understand and we want to help you guys. All right, give it a little bit more time. Let's see, getting answers in. All right, so the majority on this call don't use Solargraf, which is quite surprising. Usually we have a lot of our customers on the call, which is good. So you get to see Solargraf in action, full demo, and basically ask all kinds of questions. And then if you guys have special requests or want to look into pricing, etc., you can always schedule a call directly from our website and meet with a sales rep. All right, good. So I'll move on. Just a few slides that I want to cover really quick. So for those of you that are seeing Solargraf for the first time, what is Solargraf? So we consider ourselves an end-to-end platform that offers solar installers a seamless journey to be able to insert a lead, whether API it or enter it manually, create a roof design, enter consumption files, upload green button data, enter consumption profiles, choose from different consumption profiles that we offer as well, and then finally jump into a design, create a roof design, place panels, add a battery, and generate a customized, compelling web quote. Right. So what the design tool today allows you to do is Main features that you detect all the roof lines, obstructions, pitch, azimuth. It's all LiDAR assisted 3D modeling, and it's all industry certified. So what I mean by industry certified, we're certified by NREL, NYSERDA. We have a lot of financing partners already integrated and partnered up with Solargraf, and we're working with a lot more to bring in more value to the platform. And then we're also doing a lot of third-party work for third parties to be able to validate Solargraf production numbers. Great. So one of the highlights, I just want to run down really quick through the top features that we'll be talking about today. Is a smart PV design that allows you to place panels smartly, whether in bill or consumption offset. You have microinverter recommendations, and then it's also adaptable and flexible with different types of roofs, flat roofs, ground mounts, carports. We support it all with the smart PV panel placement. Power control systems. So this has been recently in demand. So we really listen to our customers, and this is currently a feature in beta. We have a select number of customers using it today. So this will basically show you how you can avoid main service panel upgrades, reduce a little bit of costs for your homeowners. And then the end result is a customized, compelling proposal that consists of different sections where you show financials, materials, equipment, pricing, bill offset, consumption offset, and of course, the most important thing is the electrical savings and production numbers. All right, so we're almost there to the demo. I know everybody's excited to see it. I got one more question for you guys. I'd really appreciate if you guys can give us your answers. So the question reads as, how long does it take you guys to create a solar PV plus a battery proposal? Is it less than 5 minutes, 10 minutes, 15 or more? We want to understand how much time we can save you with this tool. So I'll give it another minute or two before I pass it to my good friend, George, to start with the presentation. Okay, I see the majority of the answers are 15 minutes. So there's definitely an added value here with Solargraf as we target less than 3 minutes to have a full design and a proposal completed with all the automation set up. All right, excellent. Appreciate the answers and your participation, guys. I'm going to go ahead and switch it over to George. George, you have the spotlight. Go for it.
Wonderful. Thanks, Hisham. And thank you, everyone, for being online today. Just going to share my screen now. So yeah, we're going to run through a demo of basically creating a design in Solargraf. You know, we'll imagine it's a kind of a fresh opportunity. I'm probably going to take slightly longer than 5 minutes just because I want to walk through this in greater detail, but we have done a webinar recently where we did one in about 3 minutes, so we can dig up the recording if anyone's interested. So on my screen, you will see my project list in my Solargraf account. So we can start by selecting new project, and then from there, we'll just enter an address. If you have Solargraf connected to your CRM, maybe via an API, you could obviously sort of initiate this flow from within the CRM, and in that case, you'd have things like the address and the customer's information pre-populated. Today, we're just doing it through the UI, so you can enter this information here if you like. There's an opportunity for you to do that later, should you wish. So once we've located the site, we're sure of that address, we move on to what we call the pre-design page. And there's a few details here, but really what we're trying to do is just establish the minimum information required to create an informed design. So simple things like if it's a residential or commercial property, that's going to change, you know, which utility tariffs are available, which incentives are available. Do note that you can either create the design yourself, which is what we'll do today, or you could order that and have it delivered by our team for a minimal fee. And we also have multiple ways to create a design in Solargraf. So the one we're looking at today is the 3D design, and honestly, that's the one that most of our users are using today. So generally, nothing for you to do here. Where you're going to put a little bit more focus is on the image. Imagery is obviously a really important factor for an accurate design. We use Nearmap as our primary imagery provider. These guys are very good, very high resolution, very good coverage. They update these images multiple times a year. So more often than not, you probably won't want to touch that. But in some cases, you may need to reposition the image, maybe zoom it out. If ever you're working on new construction and the house hasn't actually been built yet, so it doesn't appear in this aerial imagery, you can upload your own custom image, let's say blueprints. And the flow is more or less the same as what we'll see today. Just note that we won't be able to detect the pitch on a third-party image, and you'll also need the length of an eave or a ridge so that we can scale that image. So like I say, more often than not, you're just checking this once. It shouldn't take more than a few seconds. And then the only other thing we really want to know is, what does the home's current consumption look like? So you'll see that the utility and tariff are automatically identified in Solargraf for you. This particular project is in NEM 3.0 territory, so you can see that the post-solar tariff has been automatically applied and our grid connection type is set to NEM 3. Nothing for us to do there. Under this section, electricity bills and consumption, this is where we want to get a sense of how much energy is being consumed today. So as Hisham mentioned a moment ago, if you have green button data, if you have the actual usage, you can select this option on the right-hand side. You can upload a file. We support CSVs or XMLs. Those can be in 15-minute or hourly intervals. And obviously that would give you an actual profile of the home's current consumption. More often than not, you're not going to have that to hand, especially at this stage when you're really just kind of creating an initial design and getting a quote out. So in that case, you just estimate the consumption. There's many ways you can do that. If you have, let's say, a dollar bill or a kilowatt hour usage value for a given time period or multiple time periods, you could enter those. You could go with a monthly average. In this case, I'll just pick an annual estimate. And we'll say that this home is consuming 8,000 kilowatt hours annually. So in the case where you've used this annual estimate, Solargraf is going to employ what's called intelligent baselining. And what that means is we take the 8,000 kilowatt hours for the full 12 months and we distribute that across the 12 months of the year. And to do that, we're really just looking at typical consumption patterns for other properties on this tariff in this part of the world. So it's going to reflect seasonality, weather patterns, and so on. Further, you can also select what we call a consumption profile, which really helps us to distribute any given day's consumption throughout each hour of the day. And especially in areas like this where we're dealing with NEM 3.0 and we're probably going to have a battery, being able to determine how much of the consumption occurs, say, in the morning or the evening, has a material impact on maybe how many batteries we need or what the ROI will be. So in this case, I'll choose a household with school kids. You can see there's a few other sort of standard profiles in there. You can create your own profiles if you wish. And that essentially gives us this two-peak curve where in the morning, we've got a little bit of consumption, kind of drops off during the middle of the day when most people are out of the house, and then a larger peak in the evening. Now, one other thing I'll mention before we get into creating the design itself is the ability to manage appliances or heavy loads. So the example we use is an electric vehicle. We said the home consumes 8,000 kilowatt hours annually, but let's imagine the home or the customer has maybe just purchased an electric vehicle, or they're thinking of doing so in the future, in the near future. In that case, that's going to add a lot more consumption, which isn't reflected in the 8,000 that we entered above. So here you can hit that plus icon. We have a pretty extensive list of all the major kind of manufacturers of electric vehicles with a library of the various models. And once you select the make and model, we can estimate sort of how far that electric vehicle will be driven per day. Let's leave that at 10 miles. And that translates approximately into an additional consumption per day, in this case, 4.2 kilowatt hours. So that 4.2 kilowatt hours is not included in the 8,000 we put above and will be added in addition. So we're not just designing a PV and storage system to meet today's need, but we're actually designing it for the need, in the near future. And the yellow part of this graph is that additional consumption that occurs usually sort of off-peak hours overnight, in addition to the existing loads in the home, the blue graph. So with that, we are ready to create the design. So quick summary there, you're entering an address, you're taking 2 seconds to confirm you're happy with the image. If you've got green button data, you can upload that. If you don't, just estimate with whatever information you have to hand. Take a moment to confirm your consumption profile and check any future appliances. All of the stuff around consumption there, that can be changed later. So it's not critical that you have everything to create your initial design. Now, we're in the design tool. The project's created. So at this point, if you needed to step away, you can come back to this later. Your work up to now is saved. In today's demo, we're really going to focus on roof, solar, and battery. So you'll see this electrical tab on the right-hand side. This is mostly around generating a single line diagram, a lot of the work that is kind of a precursor for permit generation. So that's something that increasingly Solargraf is going to help you with. We won't go into too much detail on that today, but if you are interested in generating permits through Solargraf, let us know, and we can contact you and give a bit more training and open up a beta testing for that as well. So in the roof tab, there's really two stages to this, guys. The first is to establish an outline of the roof in 2D. And the second is to render that outline as a 3D model. And when we talk about the roof, we really mean the surrounding sites. So it would include these trees as well. So step one, we've got this pen tool over here. The second option in that dropdown is labeled Detect Roof Outline. And essentially what that does is it runs a computer vision algorithm that will try to detect the outline of the roof within that image. So as you can see, it's done a pretty good job. You'll even notice on this image, we've actually got a slight distortion, right? Where the image isn't taken directly above the roof. The algorithm is trained to ignore that. So it's really trying to output something that's very regular in shape. It's the true shape of the roof. And of course, we can take a moment to verify that that's worked properly. More often than not, it will. If it doesn't, we can always correct it. But that's step one done with one click. And the second click will be down here on what we call the wizard. And the wizard is really just a series of algorithms that will, as I say, take that 2D outline and render it in 3D. So specifically what we're doing here is we're comparing that outline of the roof with the LiDAR data at the site to determine the pitch of the roof, so the angle relative to the ground of each of the roof facets, as well as the azimuth of each facet. And the azimuth is just a value in degrees, 0 being north, 180 being south. It basically tells us in which direction rainwater would fall were it to hit that part of the roof. So that gives us this wonderful 3D model. A couple of other things the wizard does for us: it finds the trees. So it first detects them in the 2D image. It then uses the LiDAR to estimate their height. And it also does the same for the obstructions. So really, we've only clicked 2 buttons and we now have our roof and our site fully modeled. We can interact with these objects. We can select a tree, delete it if we think we're going to cut it down. We could do the same with obstructions if maybe we want to reposition a pipe vent or something like that. There are ways to manipulate this design. But the idea is that the software will do most of that heavy lifting for you. One thing I will just show you is our LiDAR data. So up in the design tool, you have this eye icon, which is just a visibility menu. It allows you to show or hide various elements. So down the bottom of that menu, you have the LiDAR data. I'll just show that to you for a moment. Let's have a look at the mesh. And that really helps you to verify that the roof has come out correctly. So in this case, we can select that roof. I'm just going to pull that up and down for a moment. And really, I'm just trying to kind of best align that roof to the LiDAR. Now, ideally here, you want to see some of the LiDAR, but not all of it. That means that both the roof surface and the LiDAR itself are more or less occupying the same position. So something like this would be absolutely perfect. Another reason to take this time to visualize the LiDAR is because it gives you a sense of the shape and heights of nearby structures or buildings. So from this LiDAR visualization, we can essentially see the height of the 2 neighboring properties. Were they significantly taller than my customer's property, it might be worth me actually modeling those out, because there's a chance that they would cast shade on the property where we're going to put our solar. In this instance, honestly, it doesn't really matter. I mean, these buildings are all fairly equivalent in height. There's very little impact from, say, this building on this roof facet, which is probably where we'll put our solar. So the LiDAR is, again, very good tool, being able to actually visualize that, using it in the calculations for pitch and so on, really speeds up this process and removes a lot of human error. One other thing I'll share with you is the split screen over on this left-hand side. And what that does is essentially divides the screen into 2 windows. So on the right-hand side, you have your design, and on the left, you have 3D imagery of the site, courtesy of Google. And obviously, this is a very simple roof. We can kind of see by eye that it's come out correctly and that there's no additional work required. But were there to be any doubt, this split screen will allow you to get multiple views of that house. And again, this is just a really good way for you to just quickly double check. Okay, we haven't missed any facets. We don't have any azimuth or pitch values that look wrong. It's also maybe a good way to kind of double check some of the obstructions as well, which seem to have come out pretty well here. So that's essentially it for roof design. If I just recap again, step 1, detect the roof. Step 2, run the wizard. And then step 3 is really just sort of verifying. So make use of the split screen, make use of the LiDAR, and you can use the select tool to make changes. You know, if you wanted to adjust, say, the pitch of the roof or move the azimuth to the correct position, all of that is very doable. So I'll move on to solar now. Now that we're happy with the roof, we're going to start actually designing our system. So in the solar tab, whenever you open that tab, you'll be prompted to add panels. Typically, that's kind of the first step, although I will call out a couple of other tools or features that may be of use to you. So the first is what we call the shading wizard. And what this does is it takes a local weather file. It knows the exact coordinates because we entered those when we entered the address to begin with. And it simulates the sun passing over this model of the roof at that exact location. And it considers the impact of shade from all these trees and, you know, even from one facet to the next. And it generates 3 types of shading data. The first is called SAV, or the solar access value. So as a percentage, how much of the sun's energy does hit the roof that could, owing to the shadows that are cast by these obstructions and trees and so on. The next is what we call TOF, or the tilt and orientation factor, which essentially describes, again, as a percentage, how far away from optimal conditions is each roof facet, considering the direction in which it faces. So this one we're seeing here, this yellow facet is facing more or less due south. It's pretty much perfect. And we also look at the tilt, which is essentially the pitch of the roof. And the optimal tilt is equal to the latitude of the location. So obviously you're not going to change the roof pitch, but it tells you if you're more or less working with optimal conditions. So these two, SAV and TOF, will be multiplied together to give us what we call total solar resource fraction, or TSRF. And that is really the number that gives us the best indication of where on this roof we should put our modules to be as efficient as possible. And that value is calculated, well, all these values are calculated for every pixel on the roof for every hour of the year. So it's a really large calculation that just happened there. And we annualize those values and we give them to you in this heat map. So the whites or bright yellows denote very high TSRF. The purples or the oranges denote a lower TSRF. And obviously we're looking to work with the highest TSRF where possible. Now, the other thing that I'll point out is our setbacks. So Solargraf has its own database of AHJs. Some of you may be aware that we offer permits through the platform. We have a team that design permits for you to order. And that same team who generate those permits, they will also keep up to date with the setbacks per AHJ across the country. And those, as I say, are built into Solargraf. So normally you'll get a jurisdiction that's recommended to you. It will either be a city level, county level, or state level. And obviously we'll use the one that's the most geographically specific. And usually, I mean, my account wasn't actually set up this way this morning, unfortunately, but normally those would be applied automatically. So the moment you generate a 3D model, you'll see these gray areas at various parts of the roof. In this case, I think it's just an 18-inch setback at the ridge, and then that actually increases to 36 inches should more than a third of the roof surface be occupied by PV, which we may see as we add panels later. So again, generally not much for you guys to do here. We can actually even completely hide this from certain users if you don't want them to be able to manipulate the setbacks. But again, just calling those out so that everyone's aware of the various features and flexibility that the tool offers. So as I say, the shading heat map may help you. This is a pretty simple roof. We've got a very big south-facing facet here. This is probably where we'll put our panels. But if there is a doubt, do run the shading wizard just to give you that TSRF. Setbacks, if you want to play with it, you can, but more often than not, it will be there. So as I say, really the next step, or the first step for most users in the design tool, is to add panels. And we're going to go through kind of the manual process for doing that in a moment. But just before we do, I want to show you a fairly new feature in Solargraf that we call Smart Designer. And what this essentially aims to do is to take a lot of the guesswork out of panel placement and actually battery sizing as well. So down here in this left side menu, you'll see this wand icon. You select that, you'll get a drop down. And here you have 3 kind of use cases. So you could go with a max fit, That's just going to max fit every facet. It will have some kind of preset defaults, things like your orientation, which module you're using, your spacing, but it really just gives you a max fit. Otherwise, you could try to design a system with a specific bill offset in mind, or depending on your market and how you sell, it could be a consumption offset instead that you're trying to target. So since we're in NEM 3.0 territory, I'm going to ask the tool to design me a system that achieves a given bill offset. So here we'll choose our hardware. I'm actually going to use the IQ8H with this Q-cell panel. And since I'm in, where are we, Lancaster, California, I'm also going to ask for a battery. Of course, I'm going to use the Enphase 5Ps. So once we've defined our hardware, obviously you can choose things like your orientation. There's a few advanced settings here, like panel spacing and so on, which typically don't change from project to project. The only other thing we really want to know from you here is what is the target bill offset you're hoping to achieve? Obviously, setting that slider to 100% won't really help you much because no PV and battery system will completely eliminate your bill. But generally, we recommend, in the 80 to 90% range is realistic and generally a good target to aim for. Again, that may change based on where you are in the country. So in this case, the software is going to do that max fit that we just saw, and then it's going to periodically remove modules one by one, starting with those that produce the least. And it will keep doing that until it arrives at a system which is just large enough to achieve the criteria that we'd asked for. So in the case of NEM 3.0 territory, we're going to we've designed this system to achieve 129% consumption offset, but that only achieves a 60% bill offset. Obviously, but even if we produce more than we consume, that doesn't mean we don't have a bill. And you see those values reflected up here. So we get things like our bill offset, as well as our net savings, ROI payback. That's the solar only scenario. That's 6.72 kilowatts or 16 modules, all on that south-facing facet. Now, given that we'd asked for an 85% bill offset, the tool has also recommended 3 5Ps or 15 kilowatt hours of storage. And that's the same PV system, just with 3 batteries added, that now drives that bill offset from 60% up to 91%. And obviously your payback's a little bit longer because your initial investment is larger, but after 25-year project, your net savings is much higher. So from here, we can add the battery immediately to this design. I could also keep this design as PV only and then create a clone that has the batteries added, where we can show kind of 2 options to our customer on our quote. And that's essentially, if you're using that smart designer, at this point, you could, let's do it now. We'll create a clone, and your design is essentially finished. And then you would simply move into, things like pricing or incentives or whatever else it is that you want to change before you send your quote. So again, that smart designer, it's a relatively new feature, but super powerful. We've had really good feedback on it so far. So if there is anyone that does use Solargraf already and hasn't made use of that, I would strongly recommend playing around with it. And again, if you have things you'd like to see added to it or changed, we are all ears, as always. Now, for those that perhaps might have a few questions around maybe the aesthetic layout of the modules and so on, I do want to show you an alternative. So I'm just going to clear my work. I'll get rid of those modules for now. And if you want to do this manually, if you want to have a bit more control over where the modules go or the system size or anything like that, we do have this add panel tool. And that will open a side menu. It's very similar to what we saw earlier. So again, we choose our hardware. I'll go with the IQ8H. I'll say I want to use portrait because that's my preference. I always install portrait when I can. And then really we're just left with a choice. Do we want to use the auto panel placement mode, which is just one click and it will just fill the facet? Or do we want to use the manual mode, which is kind of a click and drag motion that will just sort of use a subset of that facet, not the whole thing? And this is probably the most useful if you are looking to achieve a certain aesthetic, because you've got a lot more control about where those modules go. There is also the single mode, where you place panels one by one. That's more often than not only going to be used when you're trying to combine portrait and landscape. So if you're a bit tight on space. Now, once those modules are on the roof, we can reposition them. We can resize the array. We can add more modules. We can remove some. Do note that Solargraf is really good with validations. So if you're playing around in the design tool, maybe you're trying to move modules around, you'll notice that as you cross over an obstruction or over a roof edge or over a setback for that matter, those panels will show in red. And that tells you that were you to release the mouse click, it will delete those panels. And the reason we have these validations in here is really because we want you to be able to put this tool in the hands of a rep and know that whatever they design in Solargraf can actually be installed on the roof. So provided that everything in roof design was done correctly, we don't want you then having people putting panels on trees or hanging off the roof or over a setback. So we're pretty, I'd say, robust in terms of those validations. So once you've got your provisional layout, I've actually ended up with an equivalent size system to what the Smart Designer gave us, 16 modules. I'll just manually calculate the production. So that will obviously calculate the shading on the modules. We do that at a slightly higher density to on the roof, and that will give us a production value. So that's 13,000 kilowatt hours in year one, and we're done. Now, one other thing I want to just touch on before we move to the battery, there's actually two things, excuse me. The first one is PCS. This is a relatively new concept in Solargraf and also I think for Enphase as well. So in some cases, this system may meet all of our criteria, but it may require a main panel upgrade. And obviously those are quite expensive, so we would like to avoid them if we can. So up here, if you select the PCS or power control icon, from here you can enter the current limit if you know that, or you can estimate it using the NEC 120 rule, which really just requires that you enter the main panel bus bar rating and server breaker rating. Now, if I change these values, you'll see that the tool will tell us, based on the current production, this exceeds the power control limits and would require that main panel upgrade. So in that case, what we'll do is enable PCS, and that will mean that essentially this system can be installed without needing to change the main panel. Now, obviously, there will be a little bit of curtailed production as a result because PCS is enabled. So we can open up this little info icon or tooltip next to our production value. And here we can see side by side, what would our production look like without PCS? So this is essentially when you're going to upgrade the main panel, or what would that production look like with PCS enabled and what's the loss? And then from there, it's up to you to kind of weigh, are we better to just do the main panel upgrade, or can we stomach that 17% loss in production and keep the existing panel? So again, that's a relatively new addition to Solargraf. Would love to hear feedback from you guys on how that works. One last thing, I'm a little bit conscious of time, but I'll keep going. One last thing I really want to call out is our downloads menu over in the top right here. So you guys have put quite a lot of work in to get to this point. You've modeled the roof, you've got your panels in the right place, all that stuff. This downloads menu will allow you to essentially extract data in return for all the work you've put in. So the first I'll call out is our roof reports. More and more you're going to run into, well, not necessarily more and more, but very often you'll run into roofs that are in kind of bad repair. These Enphase micros have a 25-year warranty. So if the roof's not in a great condition, we're probably better to repair it now before the solar goes on. And in order to know how much that will cost, we'll need a roof report. So some of you may have roofing divisions, others may be partnered with a local roofing firm. At some point, that roofer is going to need to see a report similar to this, which will tell them things like the size of the roof in squares, its pitch, maybe details on how many penetrations there are, what the total length of eave, ridge, valley, hip, rake, etc. is. And there's many places out in there you can get a report like this. Most of them will charge you a fairly hefty fee, honestly. Given that you've created this beautiful 3D model already, why not take that extra that roof report at no additional charge? So that's one that again adds a lot of value, especially if you're an existing Solargraf user who's using the 2D tool. That's one reason alone, I would say, to make the transition. The other one is our shade reports. This is mostly going to be used by financing providers. They want to, see the shading numbers. They want to see things like this SAV, TOF, TSRF. And they also want to independently verify that the design that you've created is accurate and that they can trust the production numbers that come from Solargraf. If you've, either on purpose or by mistake, forgotten about that huge tree that's hanging over the roof, your production numbers and your shading numbers will look much better than they would in the real world. And obviously financing companies want to make sure that that's not the case. So this comes in a web version or a PDF. You can share this via email the same way you would a quote. You just type in your contact's name and their email. You'll be notified when they open that report. And basically, as I say, it allows them to verify that, okay, yes, everything has been modeled correctly. There's no massive trees that have been missed. And that, again, usually is one document that is actually required to get financing kind of approved and signed off. So besides, giving them this kind of view-only window into your design, we also then document actually, the shading data. So per array, what's your panel count, azimuth, pitch of the roof, or the modules if they're tilted, and then TRF, SAB, TSRF. So roof report, shade report, both very valuable. In addition, you can get a JSON file or a DWG of your roof structure. So if you want to create your own permits somewhere else, that will give you a big head start. You don't have to recreate this model in AutoCAD or whichever tool you're using. You can also download CSV files of hourly or monthly production. The hourly production is for year 1. The monthly is for a full 25 years. Again, if you want a record of those values, you can download the CSV and upload that somewhere else or save it, do whatever you need to do with it. So again, those are a few other ones. We're again open to other reports. If you guys think of something else that should be in this menu, please do let us know and we'll get working on it. So that's roof and solar and your reports. We've looked at PCS, we looked at the Smart Designer. I will quickly just run through the battery design tool as well. So imagining that you didn't use the Smart Designer, you've created your own manual array. In that case, we jump over to battery. And in this tab, there's really kind of two sides to this. One is, you need to provide your requirements. And the other part is Solargraf will give you a recommendation on which batteries or which size battery system you need. So first, select a manufacturer. Obviously, it would be Enphase, but if ever it weren't, do note that there are plenty of other competing hardware manufacturers supported in Solargraf. So it's going to be Enphase. Enphase obviously has, its IQ battery, the 10Ts. We now have the 5Ps, so we're going to use those. Here, I'm going to say that this is grid tied, meaning the backup's not supported. That's obviously going to reduce our cost. And actually, one thing I just want to touch on here when we mention grid tied, do note that Solargraf will support separate pricing for batteries that are grid tied or grid agnostic that can support backups. So it's the controller is really the main piece that is either needed or not needed, and that changes the price. So I've brought you over to the settings just for a moment. But again, do note that you can actually define your pricing for various kind of configurations of batteries, both when it's grid tied and when it's not, when you've got the additional IQ controller. So in this case, I'll say it's grid tied. We're really just looking to optimize savings, right? We're in NEM3 territory. So that's our main goal. I'll leave that here. I'm going to say I still want 85, and then we can ask for a recommendation. So what Solargraf will do here is it will look at the consumption profile that we started with before we got into the design tool. It will look at the production values that we're getting from the solar design that we just did. And it will essentially calculate what is the minimum number of IQ5Ps that you would need to achieve that 85% bill offset. And in this case, it's come out with 10 kilowatt hours or 2 5Ps, and that's going to achieve us 88%. So it's slightly higher than the 85 that we asked for, but that's obviously because we can't install half of 5P. And really, that's essentially it on the battery design. It's just a very simple form. You get your recommendation, you can save your work, and then from here, you would likely open your quote. You might want to jump into your settings, play around with things there, whatever else it is that you would need to do. So sorry for kind of rushing through a lot of that. Hopefully some of you guys learned something. One thing I'm going to finish on before I hand it back to my good friend Hisham is the settings page. We've looked at this pricing. I just want to run through one specific page in your settings, which is called the design tool default settings. So in your Solargraf account, it's this little crank wheel icon in the main menu that will bring you to the settings page. And then, halfway down or so, you'll see this page here, design tool default settings. For anyone that is new to Solargraf or is new to the 3D design tool, I would strongly recommend that you spend a few minutes going through this page. This really allows you to write a lot of your kind of design preferences into the tool, and it saves you from having to change certain details every time you create a design or every time you edit an array or anything. So simple things like, what's your default panel orientation? If you're running the Smart Designer, what is the minimum number of panels that you want to put it on a facet? Many installers won't want the tool to just place 2 panels in one small little facet in the corner of the roof. So you can pick that number. If you're working on a flat roof, do you want to restrict that the panels be sort of aligned to the edges of that roof, or are you going to allow 360 degrees of rotation? Some installers will install everything due south for highest production, but then you've got a funny angle between the rafters of the roof and your racking or your rails. So you've got a lot of choices here around how you want the tool to behave. Simple things like spacing or tilt values, ground mounts, which we didn't look at today, how you define what a low slope is. So again, I won't run through all of those right now, but just know that you guys can customize it to the way that you like to design. And I think that's plenty from me. Hisham, I'll hand it back to you, sir.
Hey, George, we had a few questions on people who want to look at a few design simulations. So maybe just keep your screen, and then we'll read out the main ones that were called out. And guys, if you have more questions on the specific area that you want George to cover, I believe we have a few minutes before we end the session. So let's do that.
I think we answered most of the questions. There was a need for people to see the design with the blueprint, George. So if you can quickly run through one proposal or design with the blueprint. The second one is power export limit. I think people wanted to see how do you design a non-exporting system with battery. Can you show the power export limit on the pre-designed page?
Yeah, let's do that real quick. So I'll just reuse the same project that we created for the second one. We'll come back to custom imagery in a moment. So yeah, if we were designing a system that we don't want to export to the grid, essentially under settings, and we'll just go to, let's say, option 1, our first design, we'll go into utility settings. So this is kind of a similar page to what we saw earlier when we were kind of initially creating the project. And it sort of contains all the settings related to utility. So in here, you'll see something called the power export limit. And some utilities will define a specific power export limit that may vary from home to home, tariff to tariff, and so on. If you don't want this system to ever export to the grid for whatever reason, perhaps you're trying to grandfather someone onto NEM 2.0, you can simply enter 0 here. And whenever you do that, let's just apply that to all the designs that we've created for this customer. That essentially will mean that this system will never export to the grid, and we'll need to obviously have our battery in kind of a self-consumption mode at that stage. So hopefully that answers the question. We're happy to dig back into that as needed. In the meantime, I'm going to get on with our custom image. So I'm actually going to create a fresh project for this, and the exact address shouldn't matter a great deal. So let's just imagine that this is a new construction project. The house doesn't actually exist today. So when our near map image loads, we see an empty plot of land. Let's just imagine for a moment. In that case, as I say, there's an option here that says upload my own imagery. So I'll just browse there. I think I have a kind of a sample blueprint on this laptop. I'll have to check. Bear with me.
I just sent you one on our shared chat.
Okay, let me just see if I already have. Oh no, I've got one. It's probably not the best example. I'll try and dig one up, but this gives you an idea, right? This is maybe what the blueprint might look like, or at least some kind of estimation of that. So once you upload that custom image, you'll be prompted to crop the image. And the reason why we have to do this, guys, is because Solargraf will only really work with a perfectly square image. It's because in some cases we take screenshots of the design, and those will go onto a proposal or a contract, and all of those places in those documents, they have a kind of a square space ready for that image. So we really want our screenshot to be a perfect square. So in that case, I'll zoom it out a little bit.
George, your screen seems to be frozen. We're not seeing anything.
Oh dear. Let me unshare and reshare. Sorry, guys. Thank you for calling that out.
So back to your question, I think Adnan was asking where exactly the power export limit is. It is actually on the utility page where you put your consumption, which utility, and all of those things. It's right next to the. You might want to show again later, George.
Yeah, I'll come back to that in a moment. Can you guys see my screen now?
Yeah, we can.
Yeah, wonderful, good stuff. Cool. So yeah, all we did, let me just back up a second. All we did was we just hit this button here, browse, and then we're prompted to upload the image. Okay, you guys can still see that, yeah. And I say, here we go. So we've got to crop this image. We want a perfect square. So I'll zoom it out a little bit. We might have a bit of white space on either side, but that's fine. We can kind of center that box. Just we really want to make sure that the entire kind of roof plan is visible. The other thing to consider, guys, here as well is Solargraf will always expect north to be at the top of your screen, because that's the way it will be if we get an image from Nearmap or from Google or whoever else we get it from. So if you're using a blueprint or if you're taking a drone image or anything like that, please do rotate such that south is at the bottom. So you can use these buttons to rotate. And once you're happy with that, you can crop the image. And then really the only other step here would be to set the scale. So obviously you'd still want to, enter your utility tariff. I think we had a question about power export limit. It's just here. You'd want to set that. You'd want to define all your usage and your profile, which we did earlier. And when you're ready to proceed to create the design, you'll actually be redirected to this page. And why this is important is because when we're using an image from, let's say, Google or Nearmap, when we download that image from them, they will tell us what the distance is in feet or meters between 2 pixels in that image. So we already have kind of a scale. With your custom image, we really don't know. So that's why we want to know the length of an eave or a ridge. And the reason why we work with eaves and ridges is because they're parallel with the ground. So even when we look at them from above, the pitch won't influence the length. So first thing we'll do is trace a roof facet. I'm just going to pick this one because it's got a ridge. So we're just going to go around like so, back to where we started. Then we'll select the eave or ridge. So I'll just click here. I'll say that ridge is 10 feet long. I'll set the scale. And now I'll be moved back into the regular flow of the design tool. And because we know that, that little ridge that we drew, this one here was 10 feet, we know if that thing is, 100 pixels, each pixel equals, a tenth of a foot, just over an inch. So as we then, from there, we can then either trace this manually. We could try the roof detection. Keep in mind, obviously, it probably won't work as well on these third-party images. We can't really train those algorithms on a blueprint. If you're working with a drone image, more often than not, it will work pretty well. But again, if you have to trace it out manually, it's very simple. You just start at the perimeter. And once you have that in place, you would then divide the facets. I did mention this at the beginning, but I'll just reconfirm that. All the algorithms that we have that use the LiDAR and detect the pitch and all that stuff won't work on a custom image. So in addition to knowing the length of a ridge or an eave, you also need to know the pitch, which presumably if you have blueprints, you should be able to get that pretty easy.
Great, thanks, George. Just for the sake of time, I think there was one more request we wanted to cover is a quick example of a flat roof. I think we can spend another 5 minutes if we can go through that really quick. If you don't mind, George.
Yeah, no worries. Yeah, it's definitely a good one to look at. Let's have a look. I think I'll actually take this one. This is one I did with someone the other day. So yeah, with your flat roof, same flow. Most of it is honestly exactly the same. The only real nuance comes when we think about panel placement. And I'll probably create you a quick ground mount on this project as well, because that's also quite similar to flat roofs. So everything on this page is the same. It's a commercial project. We're going to create our own design in 3D. We're happy with this image. We're happy with the utility tariff. I'm going to say the property consumes, 20,000 kilowatt hours a year as an estimate. I'm going to say that this one is, let's just have a look. What do we get for our consumption profile? Let's just say it is a full service restaurant. And they don't have any additional appliances. We're not looking to add any EV chargers or anything at the moment. So from there, we create our design. The roof portion is pretty much identical to what we did for residential. Obviously, you'll be working with a flat roof, so things like the azimuth and so on are kind of arbitrary, but the tool will still pick one if it's a flat roof. So again, same flow. Let's detect the roof outline. Let's see how well that works. Okay, fantastic. It worked brilliantly. We can then run our wizards. So again, we're using the LiDAR here. It should find the pitch as flat. There isn't really an azimuth. This roof doesn't particularly face in any one direction, but the tool expects one, so it will usually identify an edge that's more or less south-facing, something that we can align our panels to. It's found a few obstructions. It's found a few trees. It's come out flat. I can use the split screen if I want, but honestly, we can see that that's correct. Now, over in Solar Design, things get a bit more interesting. You've got the same menu that we saw before. I'll use the IQ8P in this case. I'm actually going to use a slightly larger module, let's say 530 Longi one, and we'll stick with landscape. Now, this part of the menu is titled for flat roofs only. So these fields actually will impact this flat roof. They wouldn't have impacted the resi pitched roof that we did earlier. So the first thing to consider is, how do we want to align our array? Which direction does it face? So the azimuth down here, this is the kind of the most south-facing edge. So I can say parallel to azimuth. I could have it perpendicular if I wanted it to face west. In this case, we'll just stick with south-facing, so parallel. I can choose to tilt. My default settings set 5. I want to do 15 on this particular roof. We also have some advanced settings down here as well. So things like column spacing. My row spacing, I'm actually going to put that at 3 feet now, 36 inches between rows of panels. So good to define those ahead of time. We can always change them later if we want. I'll use the auto mode, so it's just going to kind of populate that roof with as many panels as possible. So these panels are facing towards this edge, which is more or less exactly due south. We're using landscape. We've got 0.4 inches between columns, 3 feet between rows, 15-degree tilt. We can then select that. We can change these properties. I might say, oh, actually a 15-degree tilt's a little bit overboard. Let's go with 5. The tool will delete the modules that no longer fit. You can always select individual panels and delete these, if you want to kind of clean up the aesthetics, as we mentioned earlier. Pretty straightforward. Let's just get rid of these two. Trying to think if there's anything else that's sort of really pertinent. I mean, that pretty much kind of covers it. I'll just quickly touch the ground mount as well. So that's a separate icon for the time being in the design tool, just below the add panel one. And this is really almost identical to flat roofs. The only difference here, well, there's actually 2 differences I'll cover. One is we don't have a roof structure to align the panels to. So rather than seeing something that says parallel or perpendicular to the azimuth of the roof, you've just got a value in degrees. And more often than not, you'll try and have those panels either south facing or west facing, depending on where you are. So we could leave that at 180 degrees. We could change that as we see fit. Next up is our panel tilt. That's the same as it is on a flat roof. Now, the only other change besides this array azimuth, where we have a value in degrees rather than just aligning it to the shape of the roof, we have this concept of stacking panels vertically for ground mounts. And we probably will bring this onto flat roofs at some stage this year. But stacking panels really just means, rather than having one panel and then 3 foot spacing and then another panel, we're actually just going to stack those on top of each other vertically. So probably easier for me to just create one to kind of better illustrate what this stacking concept is. And I'm just going to pretend that we're bulldozing these houses here. So sorry to whoever lives there. I'm going to say we want 5 panels stacked. I want them, 15 feet off the ground. The stacking spacing would be, once we stack 5 high, we have more spacing between those. So for a small area like this, it doesn't really apply. And once you've filled out this form, then simply just click and drag. So it's a bit like the manual panel placement that we did earlier on the residential roof. Just click and drag, and there you have a ground mount array. It's, as I say, it's 15 feet off the ground. That's this value down here, and it's in landscape, and we've stacked them 5 on top of each other. So obviously from there, if I didn't like that, I could change that. I could say, no, just stack them 4 high, or stack them 6 high, whatever, or 7 high. I think I clicked the wrong key there. And And again, a bit like, with the modules that are on the roof, we have pretty robust validations here. You can't place a ground mount over a tree or over another ground mount or on a roof or a structure or anything like that. And
George,
again, yeah,
sorry.
That's all right. You've got to stop me at some point, mate.
Can we just run through the proposal really quick?
Yes, definitely.
Proposal file. We'll take a minute or so.
Yeah, definitely. This system's going to be way oversized, but I don't think it really matters. We can take a quick look. And actually, it's good we're looking at a commercial project because there's a few nuances there that wouldn't show up on the residential one. So once you're happy with your design, usually most people will go to the quote. We have a what we call a web quote, which is a web version of a proposal. It's just a URL that can be shared with customers. It updates dynamically. Very powerful feature. We also do have PDFs. If you want to download a PDF, you're welcome to. But obviously, you need to send out multiple versions if you want to change things. So first thing to understand, guys, the quote is broken up into sections. We provide you, when you get your Solargraf account, with a whole host of kind of boilerplate sections, one for design, one for pricing, one for savings, etc. You guys can create your own custom sections. You could talk a little bit about your company. You could showcase some of your previous projects. Really, whatever you currently put in your quote could go in here. You can drag and drop these, so you can kind of tell that story in whatever order you're used to doing or what makes sense for you. You can also hide certain sections. If you really don't want to show, for example, a project timeline, you don't have to. So that's one thing to understand really early on. The other thing as well, here we go, got too many browser tabs open. The other thing to keep in mind is all of the colors and the fonts and the images, all those kind of basic aesthetic details can also be edited. So it can really kind of match your brand. I'm going to give this one a quick refresh because the tool that we're using for the screen share really drains my browser. So apologies for that. Let's just wait. We'll wait for it to refresh. And then I'll just give you a quick, oh, here we go. There we go. That was totally expected. Sharing was interrupted. Just resharing with you guys. Bear with me. Okay. Yeah, so as I say, we've got these multiple sections. You can customize the look and feel. One other big advantage I'd say of the 3D tool that we've discussed a lot today, kind of main topic of the webinar, is that you can actually show this in 3D to your customer. So just like we show the design to the financing guys on the shade report, you can do the same for your customer. And this is really something that, if you compare that to a 2D image that's from above, it's much more compelling. It makes the project feel much more real. So that's your design section. You can pick and choose whatever data you want to show here, whether it's system size, production, whatever. You can also model various financing options. So we've got a cash deal right now. We could have loans, leases, PPAs. All of those can be kind of pre-written into your account. So you just pick and choose which ones you want to offer to each customer. Pricing, usually it starts with a base price for solar, which is generally per watt. You would have a separate price for your battery. You can have any number of adders in Solargraf. If you want to have additional services or products that you sell, energy efficiency items. I even have some hidden costs, things like sales commissions or travel costs or whatever you would normally upsell. All of those can be written into the software. Your reps just pick and choose from the list based on what applies for each customer. All the incentives are in there. So there is a page for you to manage those, but we generally take care of most of those. This one's commercial. I actually haven't set up the depreciation. Maybe we can just quickly have a look at our pricing again and see that. So on option 1, sorry, I'm getting a bit of a delay on my screen share again. Under pricing here, you can define, federal and state income tax. And you can also define the depreciation method. So I believe this year for Macca's, it's a 60% bonus. So we do have some options there. You've got, I think, a 50 or 100%, but you can also enter your own bonus percentage as you see fit. And you can also model tax on savings, right? So if this is a business and they're going to make more profit as a reduction of energy costs, it's going to be more profitable, they're going to have to pay more tax on those savings. So we can model that as well if we want to be really, really accurate. A few other things while we're here: O&M costs. inverter or battery replacement costs. Obviously, if you're not with Enphase, probably your warranties 10 or 15 years. You might have to replace those inverters halfway through the project. Insurance, property tax. So again, I won't do a full demo on everything that the tool can do. You can talk to the sales team on that, but just know that there's a very robust, detailed financial model for the pricing and incentives and so on. Further, we also have a materials section. You can add videos or spec sheets, images here, showcase kind of what hardware you're working with. You've got the usage breakdown. It just shows kind of how production and consumption interact, and when do we import from the grid, when do we discharge or charge the battery. You've got your cumulative cash flow. Numbers don't look too good on this one because it's a slightly oversized system, but this will really help to show where the kind of break-even point is, and you know, you can pick and choose what kind of values you show here. And project timeline, one I mentioned a moment ago, this is really nice. You can customize this to, you know, however you typically manage a project, but usually once a homeowner or, you know, business owner has seen the savings and so on, the questions are more going to be, okay, how long does it take? What's involved? If it's a cash deal, you know, when do we pay you? You can answer all those questions in this timeline. Or you can just scrub that and hide it if it's not something you want to show. And then we finish up with terms and conditions. You can have as many templates of those as you need for resi, commercial, cash, financing, East Coast, West Coast, whatever you can think of. Just pick the right one, and actually your customer can sign and you guys can sign as well. We do integrate with DocuSign, so you can execute actual contracts through Solargraf. This is really just intended as a, you know, a signal of intent to move forward. So it's not a legally binding signature, but it does help to make the sale real.
Excellent. George, thank you so much for the presentation. Very helpful. I think we answered most of the questions. Again, guys, I want to remind everyone, if you're interested to meet with a rep one-on-one, go through a demo, talk about pricing, look at a specific project you're going to address, ask as many questions as you want, please go to solargraf.com and schedule a demo with a rep. We don't charge for demos, so it's free, and we'd love to sit with you guys one-on-one and understand your requirements and your questions. So I think that concludes our session today. I know we're way over time, and I appreciate all of you, the majority of you, for staying back. And if you have questions, more questions about Solargraf, feel free to sign up for a demo on the solargraf.com. We will send out a recording and a copy of the deck after the webinar, and also thanking you guys for joining. We're excited to always have you guys join our webinars. So stay tuned for the next one coming up shortly, and have a great day. Thank you, everyone. Bye-bye.
Thanks, guys. See you next time.